right, so we're going to continue to study rates, and we're going to look at a particular thing. Now, notice the rates we were doing before were all expressions. And so, what we're going to want to do is we're going to want to move into equations. And we're going to do that with a special thing called proportions. And so, a proportion is a statement that two rates are equal. Ratios or rates are equal. So I could make the statement that 5/6 is equal to 10/12, or 5 is to 6 as 10 is to 12. 5 is to 6 as 10 is to 12. Now again, with all statements or equal signs, we have this is a question saying, is this true or is this false? The equal sign asks us this question. Now when we manipulate it, we assume it's true to see what can happen. Um, so let's look at another way of writing these. We could say 12 diamonds is to 15 rubies as 4 diamonds is to 5 rubies. And so we would write 12 to 15 equal to 4 to 5, where these are diamonds and these are rubies on each side of the equation. I am trying to do something about that fan. Now, if we want to determine if they're true, what we're going to do is we're going to use the idea of a cross product. So what happens is if I have a proportion set like this, well, cross products come from the idea that if I want to clear this denominator, I multiply this side by b. So whatever I do to one side, I do to the other. And so these b's will cancel, and I get a equals b times c over d. Well, if I want to clear this d, I multiply by d, but I do it to both sides. And so I get AD equals BC. What we notice is that I multiplied down here, and I multiplied up this way. We call that a cross product because of the shape that's made by doing the work. And so the rules of real numbers and how we would clear the fractions give us this, but we can visually see the pattern if I multiply down the one side and up the other. And so we make a cross products. And this can help us figure out if proportions are true. So let's look at a proportion and then we'll evaluate it. So 4.1 is to 7 as 2.9 is to 5. So I'm going to make a cross product out of this. So 5 times 4.1 equals 7 times 2.9. Now let me do the multiplications out. 4.1 times 5 is 20.5. And 2.9 times 7 is 3, carry my 6, 20.3. So this proportion is not true. And so that proportion wasn't equal. right, let's look at another set of proportions here. Sometimes we get really complicated ratios. So I'm going to give you the ugly example from the book. 3 and 3/10, 2, 1 and 5/6 is proportional to 1 and 4/5 to 2 and 1/3. Well, this is hurting my head. Loads of fractions, loads of mixed numbers, but we're going to use the cross product. So we'll do 3 and 3/10 times 2 and 1/3 on the one side, and on the other side we'll do 1 and 5/6 times 4 and 1/5. And what I'm going to do is I'm going to convert these to improper fractions. So 10 times 3 is 30, plus 3 is 33 over the original denominator, times 3 times 2 is 6, plus 1 is 7 over the original denominator. I'll do this side also. 6 times 1 is 6, plus 5 is 11 over the original denominator. And 5 times 4 is 20, plus 1, 21 over the original denominator. Now these both have factors of 3, so that's 77 tenths. Here, is there any simplification that I can do? Well, yeah, this is 3 times 2, and that's 3 times 7, and I get 77 tenths. And so these are proportional to each other. Well, where proportions really come in handy is if we know things have a proportional relationship and there's an unknown number in it. So let's say I have negative 15 to 2 is equal to 60 to x. There's some unknown. So again, I'll use my cross product. I'll multiply this way first. Negative 15x is equal to 2 times 60, which is 120. Well, I can solve for x now by dividing both sides by negative 15. And let's see. Well, let's do the long division out. 8 is 0. Carry my 4. And so x is equal to negative 8. And so we were able to figure the unknown part of the proportion by using the cross product to expand this into an equation without fractions. This really is similar to clearing fractions, like when we had fractions in equations. So let's continue to look at some of these. So I have 51 34ths is proportional to 3 over n. So again, I'm going to use my cross product. I'm going to multiply these. 51n is equal to 3 times 34. Well, 51n is equal to 102. Divide both sides by 51. And I see that n is equal to 2. Well, we can sometimes get proportions that come up with decimal relations. We can have y divided by 9 is equal to 0.6 over 1.2. We don't need to clear the decimal here because we're going to be cross-multiplying. So I get 1.2y is equal to 9 times 0.6, which is 5.4. Now I can divide both sides by 1.2. And we'll turn this into a division. I think that's the best way to go. So I'll move my decimal place over 1 here. I'll move my decimal place over 1 here. 12 goes into 54 4 times with 6, and I'll bring down my 0, and it goes in 5 times. So y is equal to 4.5. proportions pop up a lot when we compare things or use comparisons. And so proportional thinking is a way of relating two separate ratios or rates. We'll continue exploring these in the next lecture.